Hey everyone, give us about a couple minutes as people start arriving here in person. Welcome to the live stream. Thank you so much for coming. I finally fixed the issue. If you notice, last month's video on Illustrator has not been uploaded yet because it was never recorded. We did the stream, or we did the session live, but I couldn't get the live stream settings to work properly. So thankfully I got it working now, and I will re-record Illustrator, I promise, and get it uploaded to the channel. But thank you so much for being here for Revit. We will get started shortly, so just be patient, and I will talk to you soon. Okay, need to get a fan. Okay. Feel free to get set up anywhere you want to sit. Ugh. Oh, it's pretty loud. S1 guest, and then capital SOM at symbol lowercase work. Capital SOM at symbol work lowercase. Yep. Well, we can't. Unfortunately, we can't use them.
Oh, I didn't know that. Oh, okay, no, I didn't know that.
And it's, yeah, unfortunately, these only are portables to the computers upstairs at our own desks. But yeah, sorry. I should have been clear about that.
Yeah, I don't think that was written on that.
All right, we need to get going. Let me call Alex until I get back up. Get started. Hey, go ahead and head back up. We're gonna get started. All right. Bye.
Does it make sense to just watch the demonstration or
I think you should stay because then you can ask questions, and then rewatch it after because I'll be recording it as I'm doing it. So yeah, if there's something that you wanted to check out, you can do it after the fact because you know exactly what you're looking for. Exactly. Okay, let's check and make sure everyone else is good. Okay. All right, everyone. We are going to get started. So let's see here. Let's make sure everything is in order. I'll be there in 15 minutes. Gotta work late. Let's start with that. Okay. Okay. If a call comes through, let me know because that means somebody's here and needs help getting it. Okay. Okay. All right. Hey everyone, welcome to the fifth session of You're Doing It Wrong. Just a quick housekeeping note here. I finally got the live streaming working. Last month's session was unfortunately not able to be streamed or recorded because my live streaming settings weren't working, so I will be going back and redoing that session on my own and then having that video uploaded for your use in the future. But today we're going to be talking about Revit. I'm very excited about this session because it's a program that is heavily used right now in the architectural industry. It has a lot of potential and a lot of power in the way it works. So we'll be getting into that today. This session will be a little bit more of a primer, but we'll be talking about some advanced things that experienced users can be using as well. So let's go ahead and get started. So a little bit about You're Doing It Wrong. It's a tutorial series that I started when I was in college as a way for me to basically brain dump everything I know about software into a location that others can use, because everyone would come to me during school. But I also had to get my own work done at the same time, so I was like, how about I just do this and have that be a resource for later use, but also everyone else as well, not just the students that were around me. So I partnered up with INOMA. I'm on their professional development committee, and now I'm doing more sessions that are going more in depth for professionals as well. I believe that every designer should be versed in all tools available to him or her, so they are never bottlenecked by the lack of knowledge of any specific tool. So it's always important to be in the know, because technology is moving extremely quickly, and there's a new software, seems like every day, that would be really helpful for architects to be aware of. Okay, so this is the roadmap for now. Right now we're on session 5, Revit, which is today. Sessions in the future will include Dynamo next month, Enscape and Lumion in September, GIS in October, Premiere Pro and After Effects in November, and Bluebeam in December. And then a new roadmap session will be created for 2020, so stay tuned for that. So today we're talking about Revit. Revit is an extremely powerful tool that uses what's called Building Information Modeling, or BIM. And I'll talk a little bit more about that in a second. We're going to be learning more about the software that professionals are using on a daily basis here in the States. We're going to learn how to program information and extract information from your models, and test and prove our designs with analysis. So the software in this session today will be Revit and Revit only. In previous sessions, usually I'm jumping around between a few of them, but today we're just going to be focused on Revit. Again, the file types in this session, like previous sessions before, I always talk about what file types we'll be working with today: purely vector information. And go back to previous sessions if you want to break down as to the difference between raster, which is pixels, and vector, which is math or line work that's generated by the computer. Okay, so let's first talk about what BIM is. BIM stands for Building Information Modeling. BIM is not Revit. Revit uses BIM, aka Revit is a BIM program, or a program that generates BIM technology. So BIM is basically gives architects and engineers tools to effectively build their designs, but also embed data and information in their models as well. So this allows them to export documentation, create schedules, sync multiple views together at the same time, coordinate and collaborate with all of their consultants, all of that happening in the single model that has information built into it. So BIM is extremely powerful, and it combines data basically with 3D geometry, which is great for documentation and saves a lot of time and energy in the workplace. So other programs that use BIM, ArchiCAD, which is very popular internationally, Dynamo, which is basically the grasshopper of Revit, which we'll be talking about next month, and Vectorworks. So Revit is not the only BIM program out there, just so that you're aware of the other ones that are happening. Alright, so let's talk about the fundamentals of Revit, and then we'll dive into the program. Again, this first portion is going to be a primer. A refresher for some that haven't used Revit in a while. or who want to learn Revit, and then it's probably pretty boring if you've used Revit for a while, but stick to the end and you'll get some good stuff. But we'll talk about the fundamentals first, and then we'll dive into more advanced stuff. So, levels. Revit is a program that has rules and constraints. So it's a program that will tell you no, which, if you're not used to that, is really frustrating, right? If you're used to like a SketchUp or a Rhino, which let you do whatever you want, that is not the case with Revit. Revit is highly structured and coded to be exact and basically structured. And it's constrained to certain elements that are in the model. So one of those major elements are levels. And levels determines the height and placement of elements in elevation, and we'll look at that in a second. But it's very important to be aware at all times of the levels that you have and are created, and what elements are constrained to those levels. Views. So what's amazing about Revit is that all of your views are synced because they're basically derived from the same model. So your plans, elevations, sections, and 3D views all automatically update when an element is moved or changed. So if I move a door in plan, that same door will be moved in elevation, in section, and in all your 3D views, etc., which is a massive time saver. So you don't have to remember to edit every single drawing. For example, if you're doing them all in AutoCAD, you don't have to remember to move that door in all of your drawings. Revit does that automatically. Families. So any objects that are placed in Revit are called families. And family, there are two types of families. There are component families, which are families that are downloaded and imported into the model. So furniture, plants, scale figures, or any other element you can see or place into your architectural projects. Those are families. Now, those are component families. Now, there are system families, which are baked into Revit and do not change or cannot be imported or exported. And those system families include walls, roofs, ceilings, floors, some doors and windows, although there are door and window families that can be downloaded. But these elements are hardwired into Revit and can only be modified inside Revit using Revit's commands. Component families can be modified, and I'll show you how to do that in a second, but it's a lot more freeing because you've downloaded it and imported it. So that's an important difference. And there are a lot of important dualities in Revit that we'll be talking about as well. Okay, so the age-old question, this was a question that a lot of students are dealing with, but not, I guess, a lot of professionals. A lot of professionals have in fact made their decision, but which software do we use? A lot of professionals default to Revit because it is the industry standard. Engineers and contractors are now using it. But I think the correct answer is not either or, it's both and, because both have strengths and weaknesses, and it's important to be able to utilize each software for that specific strength or weakness. So here at SOM, we heavily use both. We use Rhino for a lot of the schematic design or the early design phase, because Rhino is a lot more free and flexible for manipulating and creating geometry. That's him. Answer it. And Revit, though, is an amazing documentation tool, which is why it's used a lot more in the later phases of the project when a lot more things are concrete in terms of the building shape, overall form. Then you're filling in with Revit geometry, but there's constantly flipping back and forth between them because we understand the strengths and weaknesses of each one, and that's why we use both constantly. Some other things that Revit is used for, obviously, is 3D modeling, but also documentation, so construction documents, design development documents, schematic design, all of that documentation can be done inside Revit. All the sheets that you need for your construction docs can be done inside Revit. It's amazing for collaboration and consultant coordination, so multiple people can work on the same Revit model, and that works on a ownership basis. And there's also scheduling, so creating door schedules, window schedules, or other building element schedules can be done inside Revit. Let's talk quickly about file types. So there's, of course, the almighty DWG, which if there is a CAD program out there that's worth its salt. It can import and export DWGs. Revit uses the RVT format, and it's not backwards compatible. So if you're working, and this is very important to stress, if you're working in, let's say, Revit 2020 just came out, and you try to open that Revit 2020 file in a Revit 2019 file, it will not work. Revit 2020 will import 19 and earlier, but you cannot open a 2020 file in a 19 or 18 program. So always pay attention to when you're open or what program you're opening Revit files in. Multiple offices typically have multiple projects that were started in 16 and must continue to be worked in 16 because it's the same model that and multiple people are working on and multiple collaborators are working on. So you can break collaboration by opening a file in the wrong program. So it's always important to make sure that you're opening your Revit files in the program that it was created with, unless you intend to upgrade that file. So very important to think about and work with file types. Okay, so let's jump into the program. We're going to be going over interface elements. We'll talk about the ribbon, and then we will start creating geometry, and I'll be talking about all of the different views and schedules and sheets and components. So there's a lot to cover, so let's get started. So I actually have two versions of Revit open right now. I have Revit 2018 and Revit 2020. And I'll show you some of the differences that I found between the two, but I'll mainly be working in 2018 for now. When you start Revit, you will be prompted with a start screen that, for opening projects. I already have one opened here. What you'll see first is the general interface. If this is a brand new file, you won't see anything. But we can start creating elements soon. But let's talk about the interface. You've got your main tabs up here in what's called the ribbon. You have architecture, structure, systems, insert, annotate, analyze, and more, masking and site, which is important. So all of these tabs are highly important, and they change, of course, the way the ribbon looks and what tools are available to you when you click on them. So if you are new to Revit, of course, take the time to explore these tabs, because there are a lot of powerful tools up here. Unlike AutoCAD or Rhino, Revit is not a command entering program. They've designed the interface for you to click buttons. There are, of course, shortcuts you can use. So if you, for example, hit VV twice, you'll open visibility and graphics. That's a hotkey, but it's not necessarily a command. I'm not typing in visibility and graphics and hitting enter like you would in AutoCAD or Rhino. So that's an important distinction to keep in note. You'll see the properties in Project Browser. I personally like to move the Project Browser to the right. That way I can fully see all of my properties and I can fully see all of my views. This is important when you have 50 to 60 views going on, and if you keep it at the default, you only have this tiny little window to scroll through. I hate that. So I always dock one on one side and one on the other. That way I can see them fully. Other interface elements that are important to note. Down here are your display settings, and we'll be clicking through these once we have model elements in here. But you've got detail refinements, hidden line, wireframe, shaded. So if you've modeled before, you know what these mean. You can turn your sun on and off. You can turn on your sun paths on and off. You can isolate objects temporarily or reveal them. And you can also modify different settings here. So don't forget about these settings down here. They're very important for elements that are coming forward. Okay, so Properties panel. This Properties panel will change based on what's selected. If nothing is selected, the properties are for the view itself. So you'll see things like the scale you're working with. And the scale is really important when you're actually going into printing drawings, not necessarily while you're working. It does also help control how finely detailed your drawing looks if you're changing the scale. But this is very important when you're exporting for your sheets and exporting drawings, not necessarily while you're working throughout. Display mode. or display model is set right now to normal, but you can also set it to halftone or do not display. Detail mode, which is right now set to coarse. Coarse basically meaning if you're looking at a wall in plan, coarse will have it be a completely white pochette. If you set it to medium, it will start showing some elements of the wall's composition, which we'll be talking about when we get to geometry. But you can go in and create wall sections basically by saying, it's 1/8 inch this material, there's a gap here, there's 36 inch of this material. Anyway, but if you want to see that in your plan, you change the detail level to see those elements. There's part visibility, which I don't know if we'll get into today. Visibility and graphics, which is hugely important for all views. You can actually go in and modify what gets seen. So you can turn off things like structure, walls, floors, or when you click on the drop down, you can turn off specific elements, or you can actually change what they look like, and we'll get into that later as well. Orientation, this is very important. Project north or true north. This is important if you need to work on a file that is at an angle, but you don't want to draw at an angle, which is very annoying. You can actually tell Revit which way is true north, and then which way is project north, and have those be flippable, so you can work in one or the other. That's terrible. Sorry about that. Okay. Discipline, which is important for collaboration, etc. I don't know if I'll go all through all of these. But the important ones, crop view, which is important for controlling how much of a view you want to see. View range, which is very important for, especially with plans. View range allows you to control how much of the view you can see at one time. So how far should the plan look down? Where should the cut plane be? Typically, it's set to 4 feet off of the level that you're looking at. So if we're looking at level 1, and level 1 is at 0 feet 0 inches, which is basically the default, the ground, the cut plane for that first level will be 4 feet above. So we'll be at 4 feet. Let's say we're working on level 2, which is at 10 feet. That cut plane will be at 14 feet. You can control where the bottom is and also the view depth. So view range is very important. Be aware of that tool, because if something is not showing up that you think should be, it might be because it's above the cut plane or too low on the cut plane. So check that setting. Okay, so the others are of course very important. Phasing is in here. Let's look at views real quick. So you've got your plan views, structural plans, floor plans, and ceiling plans. You will also see elevations and sections here once they're created. There aren't any created right now, so they're not showing up. You'll see your schedules, sheets, families that you have imported or haven't imported yet, and groups. And so all of these are, obviously very important to pay attention to. So let's go ahead and start creating views and creating some geometry here, and I'll be talking about some more things as I'm doing that as well. So right now, I'm on the floor plan level 1. So what I'm going to do is draw some walls here, and Revit will periodically ask you to save your project. I'll just do that so it doesn't interrupt me too much. So I'll go into, let's see here, we'll create a folder called session 5. Copy that name, paste it here, and save it. Okay. Alright, so I went to architecture and I clicked on wall. Remember, I'm going to be drawing this wall in plan, and then I'm going to create an elevation view and a section view so I can see it in those modes as well. But I'm going to go ahead and start here. You'll see that there are a bunch of settings that pertain to this wall. You can see the properties panel changed. So I'm going to make this wall 20. You can type in or click. And you can also continue with the wall. So I'll go all the way around. I'll do 10. And then I can either use the guide to snap to 20. Okay, so I've got my wall drawn. Now if I click on a wall, I can see it setting. So right now its base constraint, which is the bottom part of the wall, is set to level 1. But there's no other levels in this model yet, so its top constraint is just set to unconnected, and it's set to a height of 20 feet. So if I want to set that to a level that already exists, I can change it from unconnected to a level, but I don't have any created yet, so I'll leave that unconnected at 20 feet for now. Its base offset, you can also set offsets from the base level, so if I wanted it to start at 2 feet above level 1, but I still wanted it to be constrained to level 1, I would just give it an offset of 2 feet in either direction. Okay, so I've got my walls here. I want to see this in 3D, and if you don't have any 3D views here, go over to the View tab and click on 3D Views, and you will see your model in 3D. Now, this 3D view is isometric only, and isometric means that all the lines are parallel. If you want to see this model in perspective, you have to create a perspective view. Which is a little weird in the way that Revit does it. It's not as free as it is in Rhino. So note that this 3D view that you see here is a isometric view. Okay, but you can see that 3D views popped up here. Once I made that view, it showed up in my panel. So I'm going to go back to the floor plan. And let's say I wanted to make a change here. Let's say I made this wall 10 feet. I've changed its top constraints, basically. So if I go back to the 3D view, I can go back and see that that wall has in fact been shortened. And you can see here that Revit has defaulted to the way walls are connected. And Revit, if a wall is of the same type or similar type, it will automatically join. You can tell it not to join by going into to where the join is happening and clicking on the little dot here. And this will allow you to change whether or not a wall is joining or not. So if you right-click on it, you can go over to Disallow Join, and now the walls will be separated. But I want them to be joined. You can also change which wall is dominant, which means that which wall extends all the way and which wall doesn't. So if you, I think you do, I think you go to, Does anyone remember how to change which wall is dominant on the join? I'm trying to remember. It's been a second. Setting usually pops up here. Okay, so that worked, but there's definitely a way that you can like click on it and it automatically switches which one it is. I think it might be wall joins. This is how you do it. Okay, so if you go to the ribbon while you're editing the wall and you click on wall joins, this will allow you to modify which wall is the dominant wall. So I think it's you can change whether it's mitered or not, or butt, or squared off. You can disallow the join. So I'll undo all that. Okay. So we'll move on from that. So let's see, what else was I going to do with that? You can do some other edits with the wall that you've created here. Actually, I'm going to go ahead and start creating some levels so I can start doing some things with that. So to create a level, what I'm going to want to do is create an elevation view and go into elevation mode, because levels are based in elevation. So you can't create a new level in a plan view, because you're looking, the plan view is a view of the level, right? So if I go over to the elevation tab and I click on elevation, I can place where that elevation will be taken. So this will be the north elevation, the west elevation, south elevation, and the east elevation. And then I'll hit enter. And now those elevation views will be created. So I'm going to rename this to north elevation. Second one I created was the west elevation, which I just double clicked on, and it took me to that view of the model. This is the west elevation. Third one was the south elevation, and then the east elevation. So I'm basically opening up these views. And I mentioned crop earlier. So this box that you see right here is the crop window that allows me to control what is seen in the view. So if your view is not big enough, change the crop. And you need to do that specifically for all the views that you want modified. You can also just turn off crops altogether. So if you turn off crop view, it will not be cropped. And crop region visible, you can also turn that off, and that crop region goes away. So just note that if your view is cropped and you don't know why, it's probably because the crop region has been, or the visibility of the crop region has been turned off. So turn it on and then crop the view as necessary. Let's go ahead and do that for all of these, so we can see the entire building at once. And I'm probably going to want to go a little bit higher, because I don't know how tall I want to make this building, but I'm going to make it tall probably. Since I work for SOM, that's just what we do. Okay. Okay. Alright, so let's create our levels. This right here that you see is level 1. So I'm going to go over to Architecture, Level, and create level 2. I'm going to have level 2 start at, let's say, 12 feet above. So that's level 2. And you can see level 2 has been created and has now been placed. And we'll do the same with level 3. So we'll have 3 levels in this building. So each one is 12 feet above the other. If you want a level's height to be changed, you can either change its overall elevation, or you can change its elevation in relation to something else. So what you see right here are witness lines, and witness lines allow you to change something's position in relation to approximate or objects that are approximate to it. So if I set this to 6, it will then set that level to, or I hit 7, to 7 feet above level 2, but overall it's 19 feet high. So I'll set this back to 12. But this is how you change your levels. Now remember that Revit constrains things to your level. So if you have a level, if you have a wall that's set to level 2 and you change level 2's elevation, it will also change the wall's elevation as well. And I'll show you what that looks like. But pay attention to where, when you modify your levels, be very careful with that. So I want all of my walls here to be constrained to level 2, and then I'll create another set of walls that are constrained, or level 1, and I'll create another set of walls that are constrained to level 2. So I've selected all the walls here. You can also select a wall, right-click, and go over to select all instances, and that will allow you to select all instances in the view you're looking at, or in the entire project. So if you've got a lot of doors, and you want to change all of the doors at the same time, this is how you would do that. So really handy tool that you should be using. And it works with walls of a similar type too. So if you've got a wall that is 8-inch concrete wall, but you have another wall that's 10 inches concrete wall, it will only select the 8 inches wall type, even though they're the same material. Okay, so I've selected the walls. I'm going to go over to top constraint. Right now it's set to not connected. But in this case, I'm going to change it to level 2 as its top constraint. Its bottom constraint is still level 1. And nothing will change until I either hit apply or move my mouse into the edit plane. So just note that if you're changing things in here and nothing's happening, it's probably because your mouse is still hovering inside the properties panel. So just move it out and the change will be applied. So now all of my walls are constrained to level 2. And again, if I change level 2's height, the walls will change as well. So let's say I make that 16. There goes the walls. So, which is really handy if you need to change multiple things at the same time. Like constrain it to an element that you know that will allow all of those different things to be modified. So let's copy. Let me go into 3D view real quick. You can click the little house at the top there. This guy, I'm going to set that to level 1 as well. Top of this wall is lower. Oh, right. Level 2. Okay. Alright, so other things to note. So right now, this wall is... we're going to talk about properties now. And the two types of properties that you have inside Revit. So everything that you see right here is what's called an instance property. That's a property that only affects the object that's selected. Now, if you click on Edit Type, what you'll be doing is changing the type properties, which will affect all of the walls in your model that are of the same type. So just be careful when you're modifying either an instance property or a type property, and make sure you're getting the result you want. So edit the things in the proper place to make sure you're getting that. So in this case, this is an instance property, but I want to talk about types and potentially create a new type. So right now there are only 2 types in the model, or 3 types. There's a basic wall, which is just a generic material at a certain thickness. There's a curtain wall, which is just a generic curtain wall of a generic thickness. It has no mullions yet, but it is basically just a glass wall. And then you have stacked wall, but we can create more or import more wall types inside Revit's family, right? Inside its systems family. In this case, we're just going to modify a couple basic walls. So when you go into Edit Type, let's say I wanted to make a 10-inch version of this wall, but still retain my 8-inch versions. So over here, we've got wall 1. I'm going to hit Duplicate, and it will create wall 2 by default. I'm just going to actually call this wall 10 inches. That way I know what wall type it is. I'll also go back to wall 1 and rename that to wall 8 inches. So now I've got 2 types. Nothing has changes between them because I haven't actually changed its structure yet. So if I go into Structure, I can change that 8 inches to 10. I can also add in additional wall elements to the wall, right? So you'll see here core boundary. So the core boundary is the center of your wall. If I wanted to add in, let's say, insert a brick type, I can do that, or a finish. So let's say finish 1, and I'm going to move it up above the core boundary, and then I can create, and let's say instead of making the structure 10, we'll make it 6. We'll give the finish 2 inches, which brings it to 8, and then I'll create an interior finish that's, let's say, finish 2, and move that down below on the inside of the core boundary. Down, 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 down. And you can change the materials here. So right now, let me give that 2 inches, which will bring us to 10 total inches. You can set the materiality. So 1 is always outside and 5 is always inside. You can see Revit tells you here, interior side, exterior side of the wall. So let's say we wanted this to be I clicked on the materials. You can import a lot of materials. Let's just say though we'll make this stainless steel. We'll make it a stainless steel wall. Why not? If you want to add additional materials, just go into Open Existing Library or Create New Material. Or I think there's another. What is the full Open Existing Library? I know there's a way to import. Oh, it's okay to do this too. Anyway, materials unassigned wall. Anyway, we'll just stick with what we have here. So you can change the, of course, it's a material, so you can change its reflectivity, transparency, cutouts, self-illumination, things like that. We'll just keep it at default for now. So I've shown the preview of the ball, so the outside ball is stainless steel now. And let's say we want the inside to be white, so we'll set it to be stainless steel carbon. Alright. We want this to be white stainless steel. How about that? Boom. Hit apply. Done. Okay. So anyway, so that's the wall. Hit OK. And now wall 10 inches has those characteristics that I've modified. And again, all of those characteristics and the data that's embedded in this wall is extractable. Right? So if you wanted to know how much membrane you had in your building, Revit knows that, and that can be placed into a schedule. So there's my new wall. All the other walls are still set to 8 inches, the basic 8-inch wall. But this 10-inch wall has been modified. Let's also make one of these walls a curtain wall, and we'll go through curtain wall settings super fast. So right now this is just a slab of glass. So if you wanted to actually add in mullions, what you need to add in are what's called curtain grids, or which are basically lines that the mullions will be attached to. So if I go over to architecture and I go over to curtain grid, I can create where the grids are going. So let's say we wanted this to have, let's see, I made it 20, but there's wall thickness, so we'll just do every 5. We'll do 5, and then we'll do an equidistant. So those are grid lines, right? So there are no mullions there yet, but that's where mullions would be attached to if you were to place mullions in the project. You can also create areas where your door can go inside a curtain grid. And I haven't talked about doors or windows yet, but this is how you can really go in and fine-tune the details of the model. So let's say I've placed a curtain grid here and I want it to move to exactly 3 feet from that line. You can do that. So now it's 2 and 3. So that's, let's say that's where a curtain wall door will go. And now I'll click on mullions. Now I can either add in mullions one by one, or I can hit all grid lines and then click on model, and all the mullions will automatically be generated. And again, Revit allows you to modify every detail here. So if you wanted to create different mullion types, you can do that. We're not going to get into that today, but it's the same process as editing the wall. You click on a mullion. If you hit Tab, Tab allows you to flip through different selections. So if you want to select a specific element, like this, this glazing spot here, if you wanted to change that to a solid material, or change it to a different wall type, you can do that, right? So now that's a solid wall inside the curtain wall. If you hit Tab, again, I'm going through the mullions. I'll select one mullion and hit Edit Type. I can then change its width, its thicknesses, its width on one side versus the other, etc. You can also see that the curtain wall is biased to a certain direction. So the glazing is actually offset. You can change the glazing offset inside the curtain wall's settings here. You can also flip the direction of the bias. So if I go into level 1 and I click on the wall, you'll see two tiny little arrows here. Hit that and it flips the wall direction. You can also change the offset of the wall on or of the curtain wall inside the walls here. You can either drag it in. So now the wall is slightly offset, which looks better than it floating outside of your building. Any questions about what I've shown so far? Okay. So I'm going to go in here. Let's say I want to go ahead and make this a door. So I'm going to hit tab until I select that specific portion of the model. There we go. Now I don't see the curtain wall door element in here. So what I'm going to do is actually import that family. So I'm going to go over to Insert. I'm going to go over to Load Family. And this will take me to Revit's family library. So you'll find, all of the default family types will be embedded here. Revit 2018, I guess it's number... Usually takes you straight to one sec. Look this up quick. Program data, Autodesk, Revit 18. I'm going to replace families in a different location. Every firm uses Revit differently. So huh. Okay. Well, I can't find where the families are located. But for you, you'll probably be able to find it when you click on Load Family. The library should be the first file that it goes to. So I'm not quite sure why it's shown there. Yeah, families. Yeah, this is the actual location where it should be. So there's that.
Okay. Nope. Yeah,
It should be right here.
So
we'll move on from that. But
you
you click on you click on the family here, or the glass. You would load the family for curtain wall glass or a curtain wall door, and then it would show up here in your library, and then you can click on it, and then that will become an actual door in your file. So sorry that that's not available for me at the moment. But okay, so we'll go back to other things here. Let's say you wanted to create a floor. First of all, you want to select the level the floor is going to be on, so we'll create the floor first at level 1. And floors and roofs are created in the exact same way. The only difference is that floors will default to thickness going down, and roofs will default to thickness going up. And then roofs have additional details that you can add in. But let's go ahead and draw a floor. You can start drawing a floor in 3D view, but it's definitely best to draw the floor in one of your plan views. So I went to level 1 plan. Right now I'm in sketch mode, which puts Revit in a different type of mode. Certain tools will be unavailable to you while you are in sketch mode until you finish sketch mode. Sketch mode will require you to have only closed objects. If there are any gaps or openings anywhere in the sketch, it will give you an error, right? So those are one of the examples of Revit saying, hey, no, fix this, and it'll tell you exactly what you need to fix, and then you can do that. So the tools for drawing are line, where you can go in and draw your polygon. You'll see it in magenta as the sketch that you're currently drawing. You can also use the rectangle tool, which is very handy. So what I've done right now is actually created a floor with a gap in it, which can be used for shafts or atriums, etc. There's the polygon tool. There's the pick line tool, which is one of my favorites. So if I wanted to be very specific as to where this floor was going, and I wanted to attach it to geometry that already exists, I can do that. So I can select those areas there, and now the floor area has been added. I'm going to get rid of those lines though, because I do not need them. And make sure when you want to select, you go back to the modify tool, so you can actually go in and select things. But anyway, and I'm going to delete this line right here. Actually, I'll delete these 3 lines. Now, to finish a sketch, you click on the check mark. Again, all objects in the sketch must be closed. So right now I have a line here that's open, and it's giving me an error that says lines must be closed loops. The highlighted line has an open end. So I'm going to hit continue and delete the part that's causing error. Again, of course, you can create multiple floor types right here. I'm going to hit check and go back to my 3D view, and there's my floor. Again, it starts at level 1 and goes down by default. And we'll create another level at another floor at level 2. So I went to level 2 and I do not see anything. Right, again, this is a view range issue, so if you want to see the floor below, there are 2 ways you can do that. You can either have the view range go all the way down to level 1, so you would see the walls, or you can turn on what's called, where's that? It's called... Huh. Do you know what I'm talking about? Where you can show the a view, another view on top of a view if you wanted to trace something or have it be a reference. It's one of these parts, graphics, orientation. Wow. It's called like a view display, where you can say, show me level 1 as a basically like an XREF in AutoCAD.
But I can't seem to find it here.
Yeah, I know it's in here. It's one of these side buttons. Underlay. Haha. That's what it's called. So level 1. There it is. So a lot of you probably watching online are like, yep, it's underlay, Paul, but you can't really tell. Anyway, underlay. So this is level 1. I can see it now. I can't interact with any of the elements in the underlay. It's just there for reference. But when I'm drawing, I can use it to select things or snap to things. So when I'm creating the floor here, sure, I'll save Project Revit. I can actually use those underlay elements to snap the floor. Bam, have it be on the inside. It's going to be at level 2. Again, it'll start at level 2 and go down by default, but I can change its offset. I'll hit the check mark. You'll see some elements here. Would you like the walls to go up to the floor's level and attach to its bottom? I'm going to check no, because I want the walls to remain as I created the walls. There's some instances where you would hit yes, but in this case, no is fine. And I'll actually create an atrium here since we're on the second floor, create some sort of mezzanine. And I'll just draw it like that. And now, no again. And now my floor has a hole in it. So there's the floor there. Any questions about sketch elements? Okay, so we've got our different views. Yep, talked about that. Talked about different levels. Okay, view range, super fast. Bottom level, I'm going to set that to level 1, or unlimited actually, is another great option. Hit apply. And I'll also set the view depth to unlimited as well. And now I can see everything below level 3. Here I'm going to draw some walls again. And I can either copy the walls from level 1 and paste them onto level 3, or I can just draw them afresh. I'll make sure they go where they need to go. And when you modify walls that are joined, all the other walls change too, which is handy. Turn that setting off if you like. Right now, this upper wall is set to unconnected because I haven't created a level 4 for them to connect to. And I'm going to change this to 10 to match that. And go back to 3. It's floating. I need to change its bottom constraint to level 2. And I can then set, I guess I can set the top constraint to 3. There we go. So there's that weird looking building. And then I'll create a roof so you can see how that's done. 3. And I'll go to plan 3. Again, same sketch tools. Now, right now, this is going to be a flat roof with its base level. Let's say I haven't created a roof level yet. Actually, well, I don't need to, I guess, if level 3 is the top. But what you can actually do on the roof sketch when you're creating a roof is you can select the lines here. Right now it's saying that it's a flat roof, but if I select the line and check defines a roof slope, then I can actually go in and define what that slope should be, and that will actually change the way the roof looks. So right now it's set to 30 degrees. I'm actually going to tell these sides to no longer define a slope, and just have this side and this side define a slope at 30 degrees, and then hit the check mark to see what that looks like. So now I've created a pitched roof that's pitched on 2 sides. There's an opening here, and I can either draw a wall that fits that opening, or I can just tell Revit to take this wall and attach it to the base of the roof. And now that wall is going all the way up. And I'll actually want to do that for all of these walls. Attach, select all the walls attached to the base of the roof, and now they're all going up and closing the top there. I'm going to set this to a height that's not as strange looking. Let's place some windows. No window families. Would you like to load some now? I'm going to hit yes, but it's not going to take me to the to the window families unless they're in here somewhere, and I just can't find them. Environments. Maybe my library didn't load when I installed Revit. So just so everyone knows, like, I'm in urban planning at SOM, so I never use Revit. I haven't used it since school, so some of the stuff I've forgotten. But hopefully it'll come back to me. But anyway, so that's why I'm missing things, because I'm not using it on a daily basis at the moment. But anyway, if you had window families loaded, you can then place them, and it's probably best to place them in the proper elevation view. Of course, you can change its placement, you can change its size, you can create modifications of each one, and place them in here like necessary. Questions about what I've talked about? Okay. So let's talk about some of the more advanced stuff, because I know some people here are super bored. If you want to create a schedule or a sheet, there are a few ways you can do that. You can go over to the project browser, right-click, and hit New Schedule. And I'm going to go in and select a portion of the model that has variation in it, which in this case are going to be my walls. So I'll expand walls, hit walls. So right now I'm going to be creating a wall schedule and hit OK. And then it's going to ask me, what element of the wall do you want me to create a schedule about? Or which elements? So let's say I wanted the area of my walls to be in there, the cost of my walls to be in there, the length of my walls to be in there, the type to be in there, and I'm just going in and adding in characteristics that would be important for the schedule, and then hit OK. And now I have got my wall schedule, which tells me all of the areas that I've created, and that can then be placed into a sheet, and it's ready to export because that data is embedded in the Revit model. Sheets are done in a similar way, so new sheet. I don't have any sheet families created. And sheet families would of course be, the sheet sizes, so 11 by 17, 24 by 36, 36 by 48, or whatever default sheet sizes you'll use. You'll create that. And I wish I could show you, but I don't have any families loaded, which is very strange. Actually, maybe I can load them this way. Bear with me for a second. Annotation. Yeah, I'm missing a lot of settings here. Oh, I haven't even talked about stairs yet. Stairs are a whole nother thing. Yeah, I'm missing quite a few families. I guess I should check that before I start. Okay. Alright. So let's go ahead and let's say we wanted to create some perspective views. I'm going to go ahead and create a site super fast. Sites are basically the environment that your model exists in. You can either create it by placing points in some strategic locations, So let's say I'll place a point here, here, and here. And now the surface is starting to be made. The next point I'm going to want at, let's say, 2 feet. So I can place that there. And now I'm starting to create some topo elevation change. And I'll also talk about building pads, which are super important. We'll hit the check mark and go into shaded view. So now I've created some topography. You can see here that my building the topography is going through my building. If you want to avoid that, you do that by creating a building pad. This will take you into sketch mode. I'll go in and trace the floor of my building. And that will tell Revit to cut out the topography in that area so it's not going through your model anymore. Of course, you want the bottom of the floor to be visible. So just make sure that if you're generating topography from scratch that you do it correctly. Or if you've imported your topography from an existing topography, you can actually generate a surface from that inside Revit, which is alright. It's not the best tool, but it works. I'll bring that back down to 1. So now let's create some perspective views. So if you go over to View and go over to Camera, I'm going to go into Plan and say I'm going to place the camera here and look at the building this way. And right now I'm like modifying where the camera is looking. And you change its field of view by expanding how much you see. The further out you go, the more distorted the view will become. And let's say you wanted to export this view. At the moment, you can place this on a sheet, and it's ready to go. You can customize its settings, materials. Right now, it's set to shaded or hidden line. But if I change this to realistic, you'll see the materials that you've added in. The materials are pretty basic right now. But let's say you wanted to export this to a drawing, right? If you wanted to do a drawing. There's some things that I've learned that are pretty cool that I want to share. So I'm actually going to turn on the sun. We'll have it be still. We'll have it be today, but today at, say, 0, say at 8 or 2 p.m. And then actually turn the sun on. And you can see the sun path, and you should be able to, shadows on as well. And let's say you wanted to set the location. You do that by going back to masking and site and going over to, or it's not masking and site, it's sunset. Location. Cool. Yeah, in the sun settings, let's set this to Chicago, which will give us the proper sun settings for Chicago. Search. Still in Boston. Okay, so let's say, actually, I want this sun to be, well, since that's north, place the glazing on the north side. So let's go in here and change this to glazing as well. Okay. So I'm going to go back to my 3D view, which is labeled 3D view 1. And I'm actually going to select the view because I want to change it. So I'm going to select the bounding box of the view. I'm going to go back to level 1, and now I can see the camera again. So I'm actually going to move the camera to the other side and then move its target point here. And that will change the way the view looks and where it's looking from. I'll expand this out again. Okay, so let's say you wanted to export a building's line work and a building's shadow for drawing. You can't do them both at the same time. If you export a drawing with shadows on, shadows are raster element. It will rasterize everything and you won't be able to edit anything. So this is how I found that you can do both. If you're making an Illustrator drawing straight out of Revit, this is how you do it. So we've got the view. I'm going to go over, I'm going to turn off the shadow. I'm going to go over to File, click on the Revit.
Or maybe it's File.
File, yeah, that's right, it's File. File, Export, CAD Format, DWG. It's of the view I've created, how much I want to see. All those settings are good. I'm going to hit Next. I'm going to give it a name and a location, so I'm going to save it to the folder. We'll call this 3D view 1, that's fine. Hit OK. Crop boundary for 3D view will be ignored. Actually, no, I'm sorry, not what we want to do. You can do that, but what it's actually going to do is export the entire model, and all the elements will be visible. In the DWG, I forgot about this. This is not what we want, what it's going to export. But we'll open it anyway, just so you see what I mean when I say not what you want. So that way you are aware of that. Just want to check on the live stream. Good. Still going well. Okay. Okay. Right. Over here. If I open up this DWG, I'm also going to launch Illustrator because we're going to put this into Illustrator. But I'll show you what this DWG looks like. It's not going to be exported as the big one. Or maybe we'll see. Super fast. I'll also go ahead and just go ahead and export the format that will allow us to edit the lines as they are seen, which is by exporting as a PDF and bringing that PDF into Illustrator. So Adobe PDF as my printer, the file name, 3D view 1, lines, save, and hit OK. It will then, okay, I have to do that again, I guess. Inoma, search file, save. All that saving, you can see that when I exported a 3D view, even though it was a perspective view, when I exported as a DWG, it brought in the entire model, which is not what we want in terms of exporting a view, but could be handy if you were working in AutoCAD for some reason and needed to work in AutoCAD 3D, which, why, but okay, if you want, you can do that. But this is pretty handy for that very specific purpose of exporting 3D to AutoCAD. Now, you can do this in any of your plan views, right? So if you exported the drawing in plan, which you can do, it will export the plan view of that drawing that you can then modify in AutoCAD. So let's switch back to hidden line. It's pretty here. So file, export, CAD formats, DWG, right? Same process, it'll export the line work there. Now, I've got the PDF where I need it to be, which is great. So I'm actually going to drop that PDF into Illustrator. So lines, Illustrator, move. Don't switch, please. Cool, so I've got my lines. I'm then going to actually flip the 11, 8.5, and then rotate these guys about. Okay, so there's my line work. I can take the time to separate everything into its respective layers, which, you know, you can take the time to do, which I recommend that you do if you're making a drawing. But I'm going to go back to the view. Now what I'm going to do is change the visibility and graphics of everything here. So there's no other way to do this, and I've looked, to export just the shadows than this process right here. And this hopefully will show you more things that you can do inside Revit. So I can either go in here and hit VV, which will launch visibility and graphics, go in and change all of these major elements to what I need it to be to export just the shadows, or I can select all of the objects that I want to export straight up. You can hold Control to add to your selection, Shift to subtract from your selection, and I'm going to turn off the sun shadow, or the sun path off. Anyway, select everything again. Right click. Oh, this is really important. When you have multiple things selected and you select filter, you can actually uncheck things that you no longer want selected. Super handy. Anyway, we'll go over override graphics in view, and this will override the elements of view view characteristics. So how they look, the transparency, the surface material. By overriding it, this will not change the overall graphic settings in other views. This is just a view-specific change. We're going to hit by element. All of the projection lines, we're going to change to white. All of the surface patterns, we're going to change to invisible. Surface transparency, off. Cut lines, white. Cut patterns, invisible. We're going to hit apply and hit OK. And now all you can see in the view are the shadows. So now what I'm going to do is go into File, Export, Image, Images and Animation, Image. I'm going to save this as a JPEG, and then call it 3D View 1 Shadows. Save. Pixels are really low, so we will not export it at, actually we'll do PNG, %, actual size, 300 PPI. Hit OK. We now have the shadows exported, and we'll place it. You could have also exported this as a PDF, which would have allowed it to be the exact same size, which, you know, we can do that as well. But anyway, I've got those two elements now of my building exported and ready to go. So you can then go in, do a rendering. If you're doing like a manual rendering or just a 2D or line work drawing with shadows on, this is how you would do that. So hopefully that like showed you some things that you can think about doing when you're making illustrative drawings. You can throw in some scale figures and you're ready to go. Questions about what I showed? Okay. Questions in general about questions you had about Revit that I haven't covered yet. Ooh. Stairs. So that's a whole thing. Revit stairs are kind of finicky. It gets better with each version. But stairs, basically, what's great about Revit stairs is that they automatically do all the necessary calculations. It tells you exactly how many stairs that you need, and it also tells you how many stairs you need before you need to put in a landing. And then you can place a landing and then continue the stairs. And you can have them be winding, so right now I've got it set to run. And it's going up from level 1 to level 2. I can also make that go all the way up to level 3. I'm going to just create the stair here. It tells me how much stair I need to make before I reach the next level. And I need 21 stairs, so let's say I build 10 of them. And I move this over here. And then create a landing. Actually, I'm just gonna, sorry, you create a new run, and it will automatically create the landing. Okay, so this stair's too big for this building. But now I've got a stair that goes from one level to another, and the stairs will automatically update with the levels as well, so that's very handy. So, and you can, like, there are tons of videos on how to manipulate stairs, so be sure to jump into those. But there are a few ways you can create stairs. You can either create it by doing a run, or you can create a boundary and create your very specific boundary. But all of the math and hard labor that comes with creating stairs is automatically done by Revit, because it's using data to do it. You can change the railing properties, you can change the treads type, you can change the riser type, the side panel type. Every single element of the stair is modifiable. Let's see. Sections, okay. Sections are just like any other view. I'm going to delete the stair. It's terrible. Actually, I'll bring it back so it looks cool in this section. We're going to go to View, Section. You can draw your section in any location. You can change how much of behind the section cut you see. You can also modify its location if you need it to be moved. And you can also flip its direction by hitting the two little arrows, and now it's showing the section cut the other way. You can see this little break line right here. If you hit the break line, you can then select a specific part of the section, or have that, have the break line be able to give you a visible break. The section is still cutting. Now, if you want the section to be split, I believe you can do that by selecting the section and hitting Split Segment. Say we want to split it right here. Now I can move that other portion of the section lower, and that creates a split section, which is super handy. So the new section view has been created. So if we click on section 1, we can now see the section of our building. You can modify cut settings that you see here. So if you want a thicker cut line, just go into the visibility and graphic settings. I think you go under Annotates, sections. No, sorry. You click on the walls themselves, or the element. Right click. Cut lines. And you can create different cut patterns. And edit cut pattern types, so you can make it a thicker stroke if you need to. Okay. Any other questions about sections? Let's see. Is there anything else I want to show? I know I haven't shown much advanced stuff. I'm trying to think what would be good to show. It isn't already being done. You can there are a bunch of opportunities that you can get into when we look at integration with other programs. So you can have AutoCAD XRefs embedded in Revit that will allow you to quickly make changes. When you make a change in AutoCAD, you can reflect that change in Revit. I don't really have any AutoCAD drawings that I can put into here, but that's a possibility. You can bring in elements from within Rhino, import them as STAs, and then have those STAs work for you here. Actually, you should be able to do that. I do have a couple Rhino files I can import. So if I go over to Rhino, and this is going to be super fast, but I'm going to create a turn grasshopper off. Zoom into origin. I'm going to create a wall here. Actually, let's do this. So I'll set it by 2 feet. Okay, I'm going to export this as a SAT file, an SAT file. Or is it STL? No, it's definitely SAT. There it is. .sat. We'll call this Rhino wall. Default settings are fine. I'm going to go back into Revit. And I'm going to go into the 3D view. Yes, we'll save the project. I'm going to go over to Insert, Import CAD. I'm going to change what it's looking for to SAT. There's my Rhino wall. You can import it in a specific category, which will change its settings. I'm going to hit OK, or Open. And now my wall is in Revit. Now this is a dumb object, which means you can't really change any aspect of this object because it is not native to Rhino. But you can actually turn it into native Rhino, into a native Revit object, which will then allow you to modify it. And let's say we want to turn this into a Revit wall. I'm going to hit Wall. And I'm going to hit Pick Faces, and it should allow me to select the face of the wall here, or maybe if I go into, let's go back to wall. I could do wall by picking a line, so I could do like pick line, go in. course it's not working. Okay. I think I remember what I did wrong. I'm going to do that again. What I'm going to do really super fast is create a custom component. And components are basically custom families. You can model it in place or place an actual family. In this case, we're going to hit model in place. We're going to go to generic. Generic models. And we'll call this wall. Okay, in here you can create custom masses, extrusions, sweeps, blends, void forms which cut holes in your objects. In this case, we're going to import our object, so import CAD, Rhino wall. Then we're going to go to create, extrusion. There we go. Haha! You can't defeat me, Revit. I'm then going to select the line here. So in this case, I'm just going to recreate it. I remember there being a tool that allowed you, and maybe look this up, but I remember there being a tool where it allowed you to select the wall and turn it into, maybe it was inside the mass editor. Maybe that was it. But anyway. I've selected that. Extrusion start and end. Let's give it. It's going to start at 1 foot. Let's say actually 0, and it's going to go up. Let's say 1 to go to 10. We're going to hit the check mark. Now we've got a version of the wall that is the same shape as the Rhino object. I'm going to move that wall over here. And let's make it taller. Let's make it 30 feet, just so we can see it. I'm going to finish model. I'm going to go back to wall. And it should allow me to pick the face. Yeah, it does. Cool. So now it allows me to pick the face. And now I will have a basic wall that is, if I delete that, there is the wall that I can then apply. So it's kind of a roundabout process. But if you want to convert Rhino geometry, or you have a crazy shape that you've created in Rhino and you want to bring it in, that's one way you can build it. You can also bring it into the mass editor and create the mass editor there. And I haven't shown the mass editor at all. That's a whole other session. It'll probably take just as long. But you can create some really cool objects within Revit and then bring it in and attach real Revit geometry to it. But yeah, any questions about what I've shown so far? There is so much more, obviously, but hopefully I've placed some things in a position where you can ask the right questions online to find the things that you're looking for. But again, next month we're going to dive into Dynamo, where we're going to basically be using the Grasshopper equivalent for Revit, and actually start coding and creating scripts for Revit geometry, which interact with Revit geometry. So that's going to be really exciting. Looking forward to that session. Yes. Yeah. For Revit. So Revit, when I'm designing in Revit, I feel very hamstrung because it's so rigid. But you can get a little bit more flexible when you jump into Dynamo. So I'm really excited about that. Stay tuned for Dynamo for Revit. Just some examples of things you can build within Revit using Dynamo. Creating scripts that that create points and adaptive components, which then Revit generates into geometry. So that's going to be a lot of fun. Okay. So thanks everyone for coming. We'll see you next month. If you have any questions, feel free to send a message on the Facebook page. But that is about it. We'll see you guys later.